In this video, we'll begin looking at some of the properties that we have for exponents and how they work. We'll start with two relatively simple properties. First, the zero power property, which says that for any real number a such that a doesn't equal 0, a to the 0 is equal to 1. So as long as the base of the exponent expression is any number other than 0, when we raise it to the 0 power, the result's going to be 1. So 5 to the 0, that's 1. Y to the 0, that's 1. All right, so that one's pretty straightforward. Next is the negative power property. For any real number a such that a doesn't equal 0, a to the negative m is equal to 1 over a to the m. Okay, so anytime we see a negative exponent, we're just going to put it in the denominator of a fraction, put 1 over it, and change that power from a negative to the corresponding positive power. Now, why do these properties work the way that they do? Let's stop for a second and kind of examine how exponents work. You know, if we think about 3 to the first power, and 3 to the second power, and 3 to the third power, and 3 to the fourth power. And if we think about the values of all of those, so 3 to the first power is 3, 3 to the second power is 9, 3 to the third power is 27, 3 to the fourth power is 81. And so really all I'm doing here is thinking about what's going on as I, create successive powers of a particular base in our exponents. And what we see happening is we see that as I move from one power to the next, all I'm doing here is I'm multiplying it by 3. And then I'm multiplying it by 3. And then I'm multiplying it by 3. Okay? And I'm just counting up, 1, 2, 3, 4 with the powers. So we see as we go up in each successive power, we're multiplying by 3. Well, let's take the flip side look at that for a second. What happens when we go the other way? What happens when we drop down from 3 to the fourth power to 3 to the third power? Well, in order to drop down from 3 to the fourth power to 3 to the third power, I'm dividing by 3. Same thing here. From 3 to the third to 3 to the second, I divide by 3. From 3 to the second to 3 to the first, I divide by 3. And this is the key to understanding what's going to go on as I go to lower powers. The next power below the first power is 3 to the 0. And so if we want to think about what that is, we would be thinking that to go from 3 to the 0 to 3 to the first, we've got to multiply whatever 3 to the 0 is by 3. And going in the other direction, to go from 3 to the first to what 3 to the 0 is, we've got to divide by 3. And that tells us what our power, or what our value for 3 to the 0 is going to be. All we do is we take 3 to the first and divide it by 3. So 3 divided by 3, it gives us a value of 1. And that's how it's going to work with any power, any base raised to the 0 power. Now, as we dip into the negative exponents, the same idea occurs. As we move counting upwards, we're going to be multiplying by 3. So if we go in the other direction, we're going to be dividing by 3. So in order to get 3 to the negative first and 3 to the negative second, what we're going to do is we're going to go ahead and divide 3 to the 0 by 3. So I'm going to take 1 divided by 3. What do I get when I take 1 and divide it by 3? I get 1 over 3, or 1 over 3 to the first. If I take 1/3 and divide it by 3, well, what do I get? If you don't know off the top of your head, we can do a quick little just investigation here. What do I get when I take 1/3 and divide it by 3? You get this nasty decimal, I'm convert that over to a fraction. I get 1/9, which you'll notice is 1 over 3 to the second. And so 3 to the negative 2 is 1 over 3 to the second. And I can continue going down the values like that. And that illustrates why the zero power property and the negative power property work the way that they do. All right. Now, there's a couple of different things that we can add on to our understanding of the negative power property. Two corollaries that I've written here. A corollary is just a mathematical idea that follows from a previous idea. Our first corollary, for any real number a such that a doesn't equal 0, 1 over a to the negative m is equal to a to the m. And so if we have a fraction and we have a negative power in the denominator, we can just move that negative power up into the numerator and change it from a negative to a positive. Okay? And the second corollary, for any real number a and b such that a doesn't equal 0 and b doesn't equal 0, when we have the fraction a over b to the negative m, that's equal to b over a to the m. So when we have a fraction raised to a negative power, in order to simplify it, what we can do is we can just invert the fraction or flip it and change the power from a negative to a positive. All right, so let's apply these properties. X to the negative 3 power, it's just a negative power in the numerator, so we're going to write it as 1 over x to the positive 3 power. Next, x to the 0. Anything raised to the 0 power is 1. So that's going to be 1. Part C here, 1 over x to the negative 4th. Now this falls into our first corollary. When we have a negative power in the denominator, all we do is move it to the numerator and make it positive. And so this is just going to turn into x to the 4th. And the last one, x over y raised to the negative 3 power. I'm just going to flip that fraction over, and that's equal to y over x to the 3rd. And later on, in one of our later videos, we're going to talk about how we can simplify this even further. Okay? Okay. Let's do a few problems here. More than a few. All right, simplify each of the following. The first line, we're dealing with numbers, so we're going to actually figure out the values of all of these. We've got 2 to the negative 3. That's 1 over 2 to the 3rd. And then we figure out what 2 to the 3rd is. That's 2 times 2 times 2. So that's going to be 8. And so we end up with 1 over 8. 5 to the 0 power. Anything to the 0 power is 1. It's just going to be 1. Part C, we've got 1 over 3 to the negative 3 power. So we're going to bring that up into the numerator and make the power positive. That turns it into 3 to the 3rd. 3 to the 3rd is 3 times 3 times 3, which is just going to be 27. Part D, we've got 3 over 2 to the negative 2. So we're going to flip that fraction and make the exponent positive. And this says 2/3 to the 2nd power, which means 2/3 times 2/3. We multiply 2/3 times 2/3. We get 4 over 9. 2 times 2 over 3 times 3. All right, now we get into some variable expressions. In part E, we've got 5a to the 3rd b to the negative 2. The only way we can simplify that, we can take the b that's raised to the negative power and drop it into our denominator and make the power positive. Notice we only move the part that contains the negative exponent. We don't move everything into the denominator just because there's a negative exponent somewhere in there. Part F, 4a to the negative 3rd b. So here we're going to take just the a's and move them into the denominator. Everything else stays in the numerator. And so we've got 4b over a to the 3rd. In part G, we've got 2 over a to the negative 3 power. So we're going to bring the a up into the numerator and make the power positive. The 2 stays in the numerator. So this simplifies to 2a to the 3rd. And then part H, we've got n to the negative 5 over m to the negative 3. The n's, since they're in the numerator and have a negative exponent, are going to move down to the denominator. The exponent becomes positive. The m's, since they're in the denominator, are going to move up to the numerator, and the power is going to become positive. And we end up with m to the 3rd over m to the 5th. All right, one more set of examples here. We're going to evaluate a little bit. Evaluate each of the following with n equals negative 2 and w equals 5. So we're going to simplify these first, and then we're going to find their values by substituting in n and w. N to the negative fourth over w to the 0. We simplify that. W to the 0 is just 1. The n to the negative 4 moves down into the denominator, and the power becomes positive. And now we want to substitute negative 2 in for n. Is 1 over negative 2 to the fourth. And negative 2 to the fourth is negative 2 times negative 2 times negative 2 times negative 2. Whole bunch of negatives, 4 of them to be exact, which means that it's going to end up leaving us with a positive product. And then we're going to take 2 times 2 times 2 times 2, which is 16. So that simplifies to 1 over 16. Part B, the only way I can simplify this is by moving the negative power into the denominator. When we do that, we end up leaving a 1 behind in our numerator. So I've got 1 over nw squared. That's 1 over negative 2 times 5 squared. Following our order of operations, we do the exponents first. 5 squared becomes 25. And then I take negative 2 times 25. And this simplifies to 1 over negative 50. Part C, the only simplification I can do, I'm going to turn that n to the 0 into a 1. This becomes 4 over w to the third. We substitute the value of w in. And then I find 5 to the third. 5 times 5 times 5. 5 times 5 is 25. Multiply that by 5. You get 125. So that's going to be 4 over 125. And then in part D, we've got a w to the negative first in the denominator, so we're going to move that up into the numerator and make it the positive power, w to the first. I don't need to write that first power, it's understood. So we end up with w over n. We substitute 5 in for w, 2 in for n, and we end up with 5 over negative 2. Alright, that concludes our first video on exponent properties. Looking forward to video number 2.